Okay, 5.2. Number 48 says draw the inverse. And I could do it on the same graph, but I'll draw it on a different graph. So -2, 1, the inverse switches them, so it'd be 1, -2. And then it goes through 0, 0, so this one, switch 0, 0, we get 0, 0. And then switch these, 1, -1 would be -1, 1. And this kind of curved going to it, to 0, and it would have to curve this way. Let's see, no, I'd have to curve this way, because it stayed pretty much 1 away and then dropped down. Stayed 1 away and dropped down, so it's this way and then this way. So over here it would look like this curve would become this curve, and then this part would go up here. Okay, so it's symmetric with the y equal x line. So that's 48. And then the other one that was a question on is 67. And 67 says find the inverse, and f of x is 2x over 3x minus 1, which is saying y equals 2x over 3x minus 1. To find the inverse, change every y to an x and every x to a y, so we get x equals 2y over 3y minus 1, and then we have to solve for y. Well, we have y in the numerator and denominator. They can't cancel because there's an add or subtract. But we can multiply both sides by 3y minus 1. That would cancel the 3 minus y on 3y minus 1 on this side. Over here we get 3xy, or 3yx either way, minus x, taking x times this and x times this, equals, and on this side these cancel and I have, or turn into 1, so 1 times that is 2y. Here's where people start having trouble. We have y on both sides. We've got to get y on the same side. I will subtract 3xy from both sides, so I'll have negative x equals 2y minus 3xy. So I subtracted 3xy from both sides. I could have subtracted 2y from both sides and added x to both sides to get the x on the other side. Anyway, here's the second place people have struggled. How do I get y by itself when we've got these? These are not like terms. But they both have a y in them, and so I can undistribute, factor out a y from these. And what would be left is y times 2 would be 2y, and y times negative 3x would be negative 3xy. Now to solve for y, I got something times it, I divide by whatever's times it. Excuse me. And I get y equals this. And y is going to be my inverse since I switched the x and y's up here originally. And so I would say the inverse of f is negative x over 2 minus 3x. Now I might say that if you had taken, not subtracted 3x from both, 3xy from both sides, but subtracted 2y from both sides, you would have gotten a positive x and a 3x minus 2. All that is multiply by negative 1 in the numerator and denominator, and it's the same equation either way. So This one or that one are the inverses to f. Okay. Oh, let's do a quick check here. Make sure this really is an inverse. Let's put a number in for x in the original one, like, let's put in 3. So I get 6, 3 changes to 6 over 9 minus 1, 8. 6 eighths. Okay, so now I'm going to put into here 6 eighths. So I'd get 6 eighths over, I'm using this one, 3 times 6 eighths minus 2. So I have 6 eighths divided by 18 eighths minus 2. 2 is the same as 16 eighths. So I have 18 eighths minus 16 eighths. So I have 6 over 8 over 2 over 8. Excuse me. Multiply by 8 over 1. And that'll cancel the 8's there. That cancels the 8's there. And I get 6 over 2, which is 3. I started with the 6 eighths and got back to 3. So that's a check that seems like it's working reasonably well. All right. That's 5-2.